This paper was presented at the JCT Traffic Signal Symposium 2025. Video coverage of this paper is provided by Highways News and sponsored by Mobius Networks, AGD, Smart Micro UK, TRL Software, Traffic Group Signals, AD Electronics, and 4-Way Consulting.
Last year, myself and John stood here and spoke to you about ImFlow on a network in Crewe. The idea was to find some funding and speak to you about phase 2 of that. ImFlow worked really well. We wanted to, phase 2, introduce the sliders, policy-driven sliders. We found the funding. Unfortunately, we haven't had time to finish the works off there. In the meantime, this little scheme came along, which was great because it's helped us prove that what we're doing is going to work down Nantwich Road this year. And really, it's a simple crossroads, peds all round, schools nearby, main bus route. Thankfully, the BSIPs came along and saved us with the funding. We wanted quick, revenue-free, simple bus priority. That we could control using the policy sliders at the same time, using the same cameras to look at pedestrian demands, pedestrian volumes, and also HGVs. So something that gave us future opportunities in the future to do other things with the junction, but funded through BSIP. So extra added benefits, no extra cost. It's only been live a week and a half.
Yeah. So
we are still collecting data. Over to John.
Okay. So our stated goals were to prove that dynamic policy changing does actually do something useful. Obviously, we wanted to improve bus journey times and obviously journey time reliability there. But also, this is an opportunity to showcase and make use of our new SWARCO smart cameras, which are AI-based video detection. These give us classified detection, useful traffic data, and they also provide analytics, and we wanted to demonstrate that it actually did those things and did so usefully. The junction that we actually trying this on is called Hightown, so it's a crossroads of Hightown, Broad Street and West Street in Crewe. There was a considerable investment earlier in the year to make the walkways wider, to make the pedestrian crossings wider, replace the controller with the P2C1. It's been running under VA up until now. So here's an aerial view of the junction. So phase A going westward, B going northward, C going eastward, and D going north to south. There is a bus station down in the bottom right that's just off screen. We thought there'd be a lot of buses there. It turns out not so many. Most of the traffic is going from the A phase from east to west, and almost as much going the opposite direction. The north-south traffic is rather less. So we put 8 smart cameras on eight poles, pointing different directions on the junction. So these are monitoring various stop lines in loops, or the equivalent of in loops, as well as the puffin crossing. So we've got curbside and on crossing detection from the same cameras. Cameras do track where vehicles go, so this is useful for calibration to make sure you're not missing vehicles, and we can see the turning percentages or actual turning counts. Looking further up the road, we've got these looking up to 60 metres away from the stop line, so that's how we can model the queue. We can see the traffic coming in 60 metres away, we know when it goes over the stop line. We also added detection for the different vehicle types as well, so that's how we can tell a bus from a car, from an HGV, from a cyclist. Pretty good cameras we found. They work at night as well, so we've got infrared, so low light conditions that they work equally well in our experience. There is also a dashboard where you can actually see the numbers, so you can see the counts. Probably too small to see from where you are, but for each hour in the day you can see a sort of bucket of what's in there. Buses, not so many, so maximum of about 5 or 6 buses an hour. They're not that many of them. And with pedestrian crossings, the data we used was actually in the school holidays, but the number of cars per hour is about the same. It's about 300 vehicles per hour total in the busiest period. School holidays really shifted the peak a bit, but the numbers were still the same, so I think the numbers are valid. We will redo this and we will do it again with real numbers. The figures we've actually got are from simulation, because we don't actually have enough running time with the real software yet. So there's another view of what the cameras can do. You can see the types. It can tell cars with trailers, motorbikes, scooters, pedestrians, you name it. AI can detect it. So the nitty-gritty of it, the policies of ImFlow, they're set up when you configure ImFlow. And it's basically a digital, you type a number in, and you can see in the columns to the right, we have a level of importance which you allocate to each thing that you want to prioritize. So that can be directions, so you can give different priority to the main route as opposed to individual side roads. You can prioritize minimizing stops, which is something you do if you're targeting air quality. You don't want HGVs stopping, then pulling away again. You can prioritize active travel, so bikes and pedestrians. I think there are advanced bicycle loops as well, aren't they?
There are, yeah.
Crossing, which we're monitoring. And obviously you can give priority to public transport. So there's a neutral policy here, and then we have one with public transit, basically buses, which has a higher number. If you look on row 9 there, you can see we've pushed that one up. Is that the one? Yeah. Public transport. Yeah, it's gone up to 9 for a level of interest. There we go. So above all the other things. So you can actually select a pre-selected policy. So we've actually got 4 defined here. So this is in the ImFlow Central. So ImFlow doesn't need a central server to do the control, but it's handy for remotely changing things and monitoring what's actually going on. We turn it off, ImFlow will still carry on as before, and you can even schedule your policies. This allows you to create new policies or even to edit them on the fly. So you can just change the sliders. You can decide I want more priority for buses, slide that particular slider up to the max. So we've done there. And that will actually in real time change what's happening on street. And you can then save that and reschedule it if you think that's a particularly good combination of priorities. It's the same thing, just bigger, so you can actually read it hopefully. So we can prioritize stops in the main direction, in other directions, same with delays. You can emphasize waiting time and queues, and then modes of travel. Okay, so we have a Vism simulation. If in the first few seconds of this you'll see a bus appear and hopefully not get held up. If it's going to play. Taking its time. What we found with this, and we've used it a lot because we always use it on every ImFlow installation. So we have over 2,000 ImFlow installations created by a central team. We basically know if you've got good data in, you'll get good results from the simulation. Obviously garbage in, garbage out. But we know we've got good data because we've got counts from the PTC1 controller, and we've also got the counts from the cameras. So we've got a very high degree of confidence that in real life it's going to be the same as our simulation in the same times of day, etc. Just runs for a minute. Okay, so there's the results, which I can zoom in a moment. So on the left, we've actually got effect on all the traffic of the different policies. So this is public transport priority, and we have the same here on the right. This is the effect on all traffic. This is the effect on buses. We've only focused on phases A and C because that's the only places you actually have any significant number of buses. But what you will see there, if I go to the next slide, we get a bit clearer. We had a great improvement in delay to buses. So from 27 seconds average for buses per in that rush hour, that delay drops to an average of 19 seconds, which is 30% reduction in delay, and a 25% reduction going in the opposite way, going west to east. We also, with simulation, enables us to play about theoretically with the distance of the in detectors. So we actually simulated what would happen if we moved the detectors from 60 meters out to 100 meters out of interest. And oops, there we go. So a couple of seconds saved on the main approach and 3 seconds on the other approach. Now the furthest we can actually see out with our cameras, as is the case with most of our ground detection, is about 60 meters. So we couldn't actually do that without putting more detectors up. I think from those numbers we conclude that it's not actually worth the time and expense of doing that. And there's the impact on all the traffic zoomed in a bit. You can see the average. It moves the distribution about slightly, but really the conclusion is it has very little effect giving bus priority on everything else just because there's so few buses. So conclusions, do you want to carry on?
Yeah, go on.
So yeah, so the policies do really work. I think we would need a busier junction with more buses to actually see the effects of juggling and balancing the priorities between buses, pedestrians, and other traffic, mainly cars. We've got a case like this where the volumes aren't too high. Just actually setting a mixed policy probably gives you sufficient benefits. You don't actually need to juggle them in real time. We suspect that on the Nantwich Road, the busier junction where the flows are much higher, like 800 plus vehicles per hour, there would be a case for balancing pedestrian priority against buses, against cars, and I think we'd see more benefits there. But the other positive from this was the smart cameras have done a fantastic job. Last year we showed the benefits by using INRIX data, which is fantastic but quite expensive. Here you can actually take your stats from any time of day. You've got it recording all the time, so you can always see what performance was like before any change and after the change, which is particularly good if you're going to play about with the policies in real time. You can say, what's my policy actually done to the traffic, and you get an objective answer immediately. Okay, that's it for me. Anything to add?
Yeah. Excellent. Well,
sorry.
sorry. Yeah, of
Jason
course.
there.
So, next steps. We are waiting to see some real-time data on the junction. It's obviously been modelled, show that in the modelling and simulation it works. We want to see it on site working. That'll be the next week or so. Then we want to add the PEDs in the mix and see just how much fiddling these sliders up and down has an effect. Then we'll introduce the not stops for the HGVs and hopefully get a little pattern for there which suits not all day. And the great thing about ImFlow is we can introduce different patterns by time of day. So in the morning when all the little kids are going to school, we can give them a bit more priority than in the middle of the day when it's just adults using the crossing. We've got 4 more BSIP junctions. We've started with a nice easy one. We've got 4 more isolated BSIP junctions. We'll take what we learned from this and we apply it there again. We're getting all the added benefit of we can do the same for cyclists in the future. We can do whatever we want really. We can add air quality monitors to the system and the basic system's already paid for by BSIP and we're just adding for it. We're all seeing how quickly policy changes. A couple of years ago, everything seemed to be air quality. Then we've had a short spurt of active travel money. Now we're all into the BSIP money. When that runs out, something else will come along. We've now got a system that we can just plug whatever detector we want, allocate it a slider and make that priority. We're also giving the decision for the priorities over to the members and the public. they're our client, they're in charge really, they pay our wages. Politics being what it is, one local member will support air quality in their area, another one will be very proactive with the cars. We can change the sliders and get the pattern to suit them. It's more their decision. At the same time, we are going to look at the Nantwich Road network. We've got the railway station there, so we've got a lot of PEDs. We've got the football ground there, we've got a lot of PEDs. That will really test it to its hilt, not in isolation, which is quite easy to do, but as a network as a whole. And we are commissioning a consultant to write a report on that. So once all the cameras are in and it's all working, hopefully by this time next year, we'll be able to stand here with some real figures.
Fantastic. We would like to thank John Jason. And thank you for being on time, gentlemen. So, although we have overrun quite significantly, as you know. So again, time for one quick question. I'm really sorry, but Mark Pledell, nice and quick, Mark, if you don't mind. We're well into lunch now.
Question for John. The cameras as detectors, could you comment on their Topaz registration status, please?
No, our plan is to get them registered by the end of the year.
Excellent, thank you. Quick enough, John?
Yep.